A new test has been designed to test for brain fartism. Among those who have the disease, the probability that the disease will be detected by this test is 0.66. However, the probability that the test will erroneously indicate the presence of the disease in those who do not actually have it is 0.24. It is estimated that 9% of the population who take this test have the brain fartism disease. Construct a table using a population of 10,000. And then we'll solve some problems with it. So the first thing we want to do is create a table. So when I think about this, okay, so I'm kind of making this table just a little bit shorter here. These people have brain fartism in the top. These people do not have brain fartism. First vertical one is those that test positive for brain fartism, and the second one is they test negative, right? So we're going to put our totals out here in red and our totals down here in red. So we are told to use 10,000 at the beginning. And we know that if 10,000 people took this test, 9% of them will have brain fartism. So we're looking for a red total here. So 9% of the 10,000 will have it. So when I do that math, 9% times 10,000, I get 900. And that means 9,100 will not have brain fartism. Okay, so now working inside. Okay, so the probability that the disease will detect, if you have it, right, among those who have the disease, so that's the top line, 0.66 is how many will test positive. So 0.66 times the 900 will give us this number. And when I take 0.66 times 900, I get 594. And working backwards, if 594 will test positive, that means 306 will test negative for brain fartism. Now, the next statement is the one that's a little bit tricky. And it says the probability of the test will erroneously indicate the presence. So that means that it's going to say, yes, you have brain fartism. And those who do not have it is 0.24. So 0.24 out of the 9,100 will be told, yes, I'm sorry, you have brain fartism. And it will be very sad, I'm sure. So we would take the 0.24 times the 9,100 to get 2184. Oh my gosh, too many of my numbers disappeared. So if 2184 test positive for brain fartism, that means 6916 will not test positive for brain fartism. And now we are ready to add vertically. So I know that a total of 2778 will test positive, while 7222 will test negative for brain fartism. So this is not exactly like the tables that you created in your packet. They're a little bit different. So now using this table, let's answer some questions. So question 1, if the test result is positive, okay, so that means we are using the 594 who have it, the 2,184 who do not, and then the total is 2778, right? This is the test positive line. So if the test is positive, what's the probability the person actually has the disease? So there is your 594, those that have it, over all of them that tested positive. So if you test positive, 0.214, you've got a 21% chance that you really do actually have it. In number 2, if the test result is negative, okay, so now I'm looking at the test negative line. So those that have it are on top, right? I'm just pulling this from your table. The knots are in the middle, the 6916, and then we've got our total, which is 7222. So we know our denominator will be 7222. What's the probability the person actually has it? That's the 306 in the top. So 306 divided by 7222 gives me 0.042. So if you are told that you do not have it, right, you tested negative, you still have a 4% chance of actually having brain fartism. And what is this called? This is called a false negative because the test result was negative, but it's wrong. So there is your false negative.